Okay, this is lesson 3 of the new topic, and today's title is electromagnets. So first of all, a recap of what we did last lesson. So can you copy out the text and fill in the 3 gaps? So pause the video here and fill in the gaps, please. Okay, now we're going to go through the answers, so you should have completed it by now, and we should now have a different coloured pen to mark and correct our answers. When a something flows through a wire, a magnetic field is also produced around it. This is of course current. So when a current flows through a wire, a magnetic field is also produced around it. The closer to the wire you are, the magnetic force. So the closer to the wire you are, the stronger or larger the magnetic force. So the closer you are to a wire, the stronger the field is, and we can remember this from the video we watched when the man had the small plotting compasses. When they were placed closer to the wire with the current flowing through it, they felt a larger force, and we could see that by them moving quicker. So the closer to the wire you are, the stronger the magnetic force. If the current stops, the magnetic field will stop. So it stops completely, it doesn't reduce, it definitely doesn't get larger. So if the current stops, the magnetic field will stop. And this last point is really important for today's lesson. So give yourself a tick if you got each of those right, and if you didn't get them right, just fill in a green or a different coloured pen. So solenoid will be a new term to you. So can you please write down the definition of a solenoid, which is a coil of wire that generates a magnetic field. So a coil of wire that generates a magnetic field is called a solenoid. So we can see in the diagram we have a wire coiled up, and around it we see magnetic field lines. So there's a north pole and a south pole, and we can see the magnetic field lines moving away from the north pole and towards the south pole. So just like we've seen before, away from the north pole and towards the south pole. The magnetic field generated by a solenoid is actually identical to the magnetic field generated by a bar magnet. So these are the two side by side. And on the left we have the North Pole on the right and the South Pole on the left, and the magnetic field lines are pointing away from the North Pole and towards the South Pole. And in our diagram on the right, which is our solenoid, again we have our magnetic field pointing away from the North Pole and towards the South Pole. So the fields that the two of them generate are the same. So let's move on to our next diagram. As you can see here, we have a wire which is coiled around an iron nail. So we know this to be a solenoid. Solenoid being a coil of wire that produces a magnetic field. And this coil of wire is connected to a cell, which is a power supply. And a solenoid connected to a cell is called an electromagnet. So an electromagnet is made up of a coiled wire connected to a power supply. The electromagnet only works when the switch is turned on, and this means that electromagnets are temporary magnets. Temporary magnets, they are not on all the time. So when the switch is off, as it is in the diagram, this will not be acting as a magnet, so it won't be able to pick up any magnetic objects, It will only work when the switch is put into the on position, and as soon as it's turned off, then we say it's demagnetized and it's no longer a magnet. This is different to bar magnets that we've looked at before, because bar magnets are permanent magnets and they cannot be turned off. Another difference between electromagnets and bar magnets or permanent magnets is that you can change their strength. So how can we change the strength? The first way is by wrapping our coil of wire or our solenoid around a soft iron core. Now, the type of metal is important. So iron is really good because it can be magnetised and demagnetized quickly. If you use a metal such as steel, after it's been magnetised, it will stay a magnet for a long amount of time after, which is not what we want when we're making a temporary magnet. So the first way to increase the strength is to add a soft iron core. The second way is to increase the number of coils. So the more coils around the wire, or the more coils in the solenoid, the stronger our electromagnet will be. And the third way is to increase the current flowing through the circuit. So if we have a larger current flowing through the circuit, a larger current flowing through the wires, then our electromagnet will be stronger because we are generating a stronger magnetic field. So in your notes, please make sure that you have a diagram of a simple electromagnet such as this one, and write down the features of an electromagnet, so that it's a coiled wire connected to a power supply, it's a temporary magnet so it can be switched on and off, and can you write down the 3 ways to increase the strength of an electromagnet. Once you're happy with your notes, can you follow the YouTube link on Google Classroom to a video called Using Electromagnets, and make notes of common uses of electromagnets in everyday life. After that, can you please complete the worksheet? This involves drawing a graph from a table of results. The graph paper is given to you in the worksheet, so you can just draw on the grid given. If you're working in your books, you will need to use a pencil and a ruler to draw your graph, which is really important, and you'll have to decide your own axes. So it is a lot easier to do it by editing the worksheet, but if you're doing it in your book, you can still do it, but it might take a little bit longer. Okay, great. Please use the comment section if you have any questions, as always.